Okay, welcome to lesson 36. Now let's have a look at some operations on sets in Python. We have intersection, union, subset, difference, and the last one is symmetric difference. So let's define three sets. S1 equals 1, 5, 6. S2 equals 6, 10, 2. S3 equals 11, 22, 5. So it doesn't matter if we have different number of elements or the same number of elements. So here, all of them have 3 elements. So let's talk about intersection. So in discrete math, we use this symbol for intersection. So let's have a diagram. So we have two sets, A, B, and we want to find the intersection of A and B. So the intersection is this part here, the common part of A and B. So here I can say x equals, because I want to store the intersection of two sets into another variable. So the intersection of S1 and S2. So S1 dot intersection. So this is the name of the method. Inside parentheses, you have to write the name of the second set, which is S2. And then if you print x, the answer is 6 because, so as you can see here, the common element here is 6. So the output is 6 as a set. So let's have another intersection, S1 dot intersection. So this time I want to find the common elements among S1, S2, S3. So here you can have more than one arguments. So here we have S2 and S3. Let's print x. So what are the common elements here? We don't have any common elements. So we don't have any element which belongs to all 3 sets. So we will get an empty set. Do we have a shorter way to find the intersection of 2 sets? Yes, you can use the ampersand symbol. So it means and. So here you can say print S1, the ampersand symbol, S2. And you'll get 6. So this is a shorter way to find the intersection of 2 sets. Now let's have a look at the union of 2 sets. So let's say x equals S1 dot, the method is union, S2. So let's have the diagram here. We have 2 sets, A and B. What is the union? The union means all the elements from set A and set B. So here we have to include all the elements. So if you print x, you'll get 1, 5, 6, 10, 2. 1, 5, 6, 10, 2. But here we have 6 and 6. So remember, in a set, we can't have duplicates. We have unique elements. So do we have a shorter way to find the union of two sets? Yes, you can use the vertical bar, which is OR. So you simply say S1 or S2. So this is the vertical bar, and here you will get the same answer, 1, 5, 6, 10, 2. So as you know, a set is unordered. You might see something different, like 2, 6, 10, 5, 1. So the next one is subset. So we want to check if a set is a subset of another set. Now let's have two different sets. A equals 5, 21, and set n equals 16, 100, 5, 13, 66, 1, 30, and 20. So here let's check if A is a subset of n. So when I say a subset, we can have subsets or proper subsets. Let's have a variable, check equals. So I want to say A is a subset of n. So how to check? A dot, and the method is subset n. So we have to use is subset method. So it returns either true or false. Now let's print check. So let's see. We have 5, 21. We have 5, we have 20, we have 1. So we have all the elements of A in set n. So A is a subset of n. So in this case, A is a proper subset of A because A is not equal to n. So it returns true. And this is the symbol A subset of B. Do we have a shorter way like this to find the subset? Yes. Print, you say A less than or equal to n. So we don't want to check if the value of A is less than or equal to the value of n. So it means we want to check if A is a subset of n. And again, the answer is true. So this is the shorter way to find if a set is a subset of another set. So the next one is the difference of two sets. So let's have another set. Set 1 equals 10, 20, 30, and 40. set2 equals 25, 10, 40, and 60. So let's have a diagram to show what it means. So here, if you say A minus B, or you might see A / B. So it means the elements in A, not the element of B, not the common elements, just the elements in A. So this is the meaning of difference between two sets. Now let's declare a variable and store the result into the variable. So set1 dot, now we are using difference method, difference set2, and then let's print res. So what do you think? Just the elements in set A, not the common elements, not elements of set 2, just the elements in set A. So can I consider 10? No, because we have 10, so 10 is a common element. No. What about 20? Yes, we can have 20. What about 30? Yes, we can have 30. What about 40? No, we can't, because 40 is a common element between these two sets. So this is the answer. And do we have a shorter way to find the difference? Yes, you can use subtraction. So you simply say set1 minus set2, and it gives you the same result, 20 and 30. So this is the shorter way. And the last one is the symmetric difference. The symmetric difference between two sets. So I'm going to use the same sets, set1 and set2. So let's say res equals set1 dot. Now this is the method. Symmetric underscore difference. So this is the name of the method, and then the second set, which is set2. So let's have the diagram here. So we have A and we have B. So a symmetric difference is all the elements in A and B except the common elements. So we have all the elements in A and all the elements in B. So we have to exclude the common elements, the elements which are in both sets. And here, if I print res, I will get 20, 30, 25, and 60. Now let's see these two sets. Can I use 10? I can't, because 10 is a common element. What about 20? I can use 20. What about 30? I can use 30. What about 40? I cannot, because 40 is a common element. Now let's go to set 2. 25, yes. We have considered 10. We have considered 4. Yes, we can use 60. So this is the answer to find the symmetric difference between two sets. So that was all for this lesson. So in the next lesson, we will discuss functions, how to define a function, how to implement a function in Python. So as usual, take care and bye bye.